Welcome, everybody. Today we'll be doing our second lecture from Unit 6 from the College Board on energy. We're going to be focusing in on parts of topics 6.3 and 6.5, fuel types and uses, and fossil fuels. Special focus for today will be on coal. Next lecture, we'll address the same two topics, 6.3 and 6.5, but through the lens of oil or petroleum and natural gas. Enduring understanding is that humans use energy from a variety of sources, resulting in positive and negative consequences. To follow along in the textbook, you ought to go to pages 430 through 435, which is section 14.4 from the Miller textbook, chapter 14. All right. So let's just quickly define fuel. So fuel is a combustible material. Could be a solid, could be a liquid, could be a gas, and we would use that fuel for things like heating. We could use it for transportation. We could use it for generating electricity. All right. So examples: wood and peat, not as commonly used, at least on large scale, as they used to be. Um, Coal, oil, and natural gas would be our fossil fuels. Those are examples of fuels, of course. Propane is another example. And we also have hydrogen gas, which is sort of a unique fuel. Um, Worth pointing out at this time that all of these, minus hydrogen, contribute to the increases in atmospheric carbon dioxide when we burn them. All right. Hydrogen gas, on the other hand, does not produce carbon dioxide when burned. So interesting fact there. All right. Let's talk just briefly about wood and peat before we get into coal. So wood uh, is still heavily relied upon in our developing world because it's easily accessible and it doesn't really require any sort of special infrastructure. You can chop wood and burn it in something as simple as a wood stove. Like natural gas, for example, is burned to heat homes as well, but it requires special plumbing and some sort of centralized system to get natural gas out to homes or a big propane tank or things like that. Right. So very little infrastructure technology needed to use wood. So it's still really relied upon in our developing world. Lots of people, though, in the U.S. Still have wood stoves because they have access to wood and it's a supplemental fuel usually. All right. Peat, in case you not don't really know what peat is, it can often be like a precursor to coal, but basically it's partially decomposed organic material. Um, and it's cut from what are called peat bogs, this is what you're seeing in the background here. This is an example of a peat bog in Ireland, right? And it's kind of separated into these bricks. So these are piles of peat, and they'll be separated into bricks that can dry, and then it can be burned much in the same way as something like wood could be. Um, Not really an important fuel source anymore. Still somewhat used maybe in Ireland, but by and large, it's kind of been abandoned for other fuel sources. All right, so let's talk about coal today. Um, so coal is actually a mineral, originally formed from the burial and compaction of old swamp plants, probably upwards of 300 million years ago. MYA would be 300 million years ago. All right. Um, so coal does come in different grades or qualities, if you will. So if you look at the list below here, so kind of based on the temperature it was exposed to as it went through its chemical changes and how tightly compacted it was and so on, we get different qualities of coal. And by quality, it's basically referring to the energy density. So per pound of coal, for example, how much energy could we get out of it? How cleanly does it burn and so on? So lignite would be like our lowest quality, anthracite being our highest quality. Here in the US, we have a ton of coal, by the way, a good reminder there. A lot of it being of that bituminous type. Okay, but anthracite is our highest quality coal. Um, Now, as far as like future resources of coal, there's a lot of coal still in the ground. A lot of people would argue that it just needs to stay there. Uh, but in terms of new discoveries of large deposits of coal, they think they've pretty much found all deposits and identified them, whether they're actually currently extracting from them or not. They don't really think they're going to find any real sizable new deposits of coal. Unlike things like oil and natural gas, I think there's still a lot to be discovered still. All right. So what do we use coal for? Now, uh, once upon a time, we used to use coal for powering things like steam engines and so on. And those have been replaced by and large by diesel and electric. So nowadays, we mine coal almost exclusively for the purpose of producing electricity. Uh, in the developing world, they do still occasionally use coal for like heating and so on. But the air quality associated with burning coal, like in households, is not good. All right. So when we use coal for electricity, this is a really important process that we're going to have to know because it does not just apply to coal, but this is where we're going to bring it up. So basically, the steam turbine generation system, which is the vast majority of how we produce electricity in the developed world. It's what we use for nuclear power, it's what we use for coal power, it's what we use for natural gas, and in some cases, geothermal. But the way this works is you burn a fuel to boil water. So in the case of coal, you would burn coal in a furnace, right? And use the heat from the combustion to boil water. The boiling water, of course, creates steam they can put under high pressure. The high pressure steam is then used to spin a turbine, right? So a turbine is basically referring to a mechanical device with some sort of paddle wheel type system that will spin when something pushes it, right? And as that turbine spins, um, it spins a magnetic shaft inside a coiled copper wire. And when that magnet spins inside that coiled wire, that causes electrons to travel through the conductor, and there is your electricity. So again, uh, really, really important, just basic step-by-step process by which our fuel sources are used to create electricity, right? If it's not coal, you just replace coal with natural gas. You burn natural gas to boil water. Boiling water creates steam. For nuclear energy, they're not burning it per se, but they use the heat from a nuclear reaction to boil water, which creates steam, which spins a turbine, which spins a generator. Um, with geothermal energy, right? You use heat from the interior of the earth to boil water to create steam, which spins a turbine, which spins a generator. Now, so this turbine generator systems, particular steam turbines, are heat generated. Now, you could take a wind turbine, for example, right? Boom, and you've got your big paddles there. In that case, the the paddles or the turbine blades are themselves the turbine. So the air spins that turbine, and then up in the top of that tower is a generator, which would be a magnet inside a copper coil that spins electrons. All right. So again, really, really important to understand the basic process by which we create electricity. All right. So what are some benefits of coal? Obviously, coal is an important resource. If it wasn't, we would not rely so heavily upon it. Okay. Um, it was pretty cheap and abundant, particularly here in the United States where we have a lot of it. Okay. Uh, it is a reliable electricity, so it's not dependent on sunshine or air like wind and solar. We can burn coal any day of the year at any time of the day to produce electricity. Um, it's a pretty decent like return on investment. So it takes energy to get energy, of course, and you guys should have read that in chapter 14 in that first section. So, of the amount of energy it takes to get the coal out of the ground, we get a fair amount of return back on that. I'm not sure what the exact ratio is, but it's pretty darn high. Um, and then again, it operates off of pretty old technology, so we don't need super specialized systems to operate it and make it work very well. All right. And some other things, other considerations for how coal might be used um, is to supplement things like our petroleum products. They can use the compounds in coal and liquefy them, so it could become a liquid fuel, very similar to like diesel or gasoline. Or it can be gasified, and used similar to natural gas. And the reason you might consider that is, like in the U.S., for example, because we do have such a large supply of coal, it could be used to supplement shortages in petroleum or natural gas if or when those shortages arise. All right. Um, so downsides or disadvantages to coal. It's mined. So unlike oil, where we might drill a hole and pump it out from underground, coal is a mineral, and we mine it. We mine it in very, very large quantities, right? And so we have the typical issues with mining that we talked about back in the beginning of Unit 5, right? So with like acid mine drainage, et cetera, and habitat destruction. Okay, but because coal mining operations are so enormous in nature, um, we end up some pretty profound aesthetic impacts and habitat destruction. And probably the most destructive type is what they call mountaintop removal, which is what you're kind of seeing a model over here. So in places like West Virginia, for example, where their coal mining is really important industry, right? The coal comes in these seams, right? Again, these are like old, buried and compacted layers of swamp plants that over tens to hundreds of millions of years have gone through geologic uplift into mountains, right? And so, in the case of what they call mountaintop removal, as the name implies, they are literally scraping off layers of mountains, getting the coal, scrape off another layer, uh, flattening mountains and filling valleys. Very, very destructive form of mining. Um, it takes place in the eastern United States. All right. And then, of course, once we've taken the coal out of ground and we burn it, there are impacts to the burning of the coal. All right. So, as mentioned back on one of the earlier slides, burning coal releases large amounts of carbon dioxide into the atmosphere. Carbon dioxide is a really important greenhouse gas. And we'll talk about that greenhouse effect a little later. But of all of the fossil fuels, coal, oil, and natural gas, coal has the largest footprint in terms of the amount of carbon dioxide produced for the amount of energy that we get out of it. All right. Um, Now, coal is not pure, right? It's got impurities in it, things like mercury and sulfur and so on. And so when we burn coal at high temperatures, we produce not just carbon dioxide, but we can produce mercury vapor, which can get out into the air. It produces sulfur oxides, which can lead to things like acid rain and cause forest destruction and leach nutrients out of soil. We also produce fairly high quantities of nitrogen oxides, which happens with high temperatures in a high nitrogen atmosphere like what we have. Okay. Um, so like I said, the sulfur oxides primarily, but nitrogen oxides as well can contribute to acid precipitation and so on. All right. So what you're kind of seeing in the background there is a forest that has been ruined through acid precipitation, leached all the nutrients out, and killed off that forest. All right. So key takeaways, right? Advantages of coal: it's cheap and abundant, right? It's available 24/7, so we can have on-demand electricity that's not reliant on sunshine or wind, right? Um, and we can run coal off of existing technology. It's a very low technology enterprise. Uh, and right here in the US, we are sitting on top of the world's largest supply of coal. Disadvantages, of course, uh, are its contribution to climate change and global warming through carbon dioxide. And then, of course, the habitat destruction that accompanies mining and the air pollution that accompanies the burning of that coal.